All right, so number 7, we have this 18 kilogram mass. It's being pulled by a rope at a 20-degree angle, and friction's present. The coefficient of friction is 0.5. The displacement of the mass is 20 meters, and we're told here that the object, the mass, is moving. Where does it say? Right here. Constant speed. Okay, what does constant speed mean? 0 acceleration. What about change of kinetic energy? 0. So look, so these initial problems in the Chapter 5 homework set, you're using this equation. Work net equals change of kinetic energy. Well, if it moves at constant speed, that means the change in kinetic energy is 0, which means what? The net work is 0. Well, how is the net work going to be 0? The net work is going to be 0 because why? How many forces are doing work on this object? Is the normal force doing work? No. Why is the normal force not doing work? Because it's perpendicular to the motion. Forces perpendicular to the motion don't do any work. Is mg doing any work? No, it's perpendicular to the motion. Okay, so which two forces are doing work? Tension and friction, right? And remember, the sign convention for work done in the direction of motion is plus, work done against the motion is minus. So the tension is doing positive work or negative work? Positive work. Friction is doing negative work, right? So the thing that has to be true here, since there's no change of kinetic, that means the net work is 0. Well, if the net work is 0, what does that tell us about the work done by tension and the work done by friction? They're equal. These two works are equal. Okay, so let's just set this up. So work net is going to be 0. Okay, well, what is the net work going to be? The work net is going to be the work done by the tension minus the work done by the friction, right? Or in other words, work of tension equals work of friction. Does that make sense? Okay, now what's the basic work equation? Let's plug in the basic work equation. Work equals force times displacement. So what can we say about the work done by the tension? Well, look, is tension parallel to the displacement? So what are we going to have to do? We're going to have to break this guy into components. Tension has x component and y component. The x component is parallel to the motion. So when we do work of tension here, what we're going to say is, I'm just using this equation right here. So we're going to say cosine 20 times t. So what is that? What's cosine 20t? That's the x component of tension. Then multiplied by the displacement is going to be equal to the work of friction. So this is going to be friction times displacement. Now what happens to these displacements? They cancel. The displacements drop out. Okay? All right, so now we're going to have to do some substitution. What is friction? What's the equation for friction? Mu times normal force. So we're going to have to plug that in there. But then that brings up another question. Well, what's the normal force? And here's where the problem becomes more complex than... I wouldn't really give this to you on a quiz because here's where it gets complex. To get the normal force, you have to do some Chapter 4 stuff. To figure out what the normal force is, you have to sum the forces in the y direction. So in the y, you're going to go normal force plus this guy plus sine 20t minus mg equals may. Is there any acceleration vertically? Nope, that goes to 0. So the normal force will be mg minus sine 20t. So this is going to get plugged in there for the normal force. So here's where the algebra gets real fun. Okay, so back to here. So we have cosine 20t is equal to, so friction is what? Mu times normal force. But what's the normal force? The normal force is mg minus sine 20t. Okay, so now you got to distribute the mu. Cosine 20t equals mu mg minus mu sine 20t. Okay, so the only thing missing in there is t. So you can do the algebra, and t comes out as 79.4. Look, my advice to you, I mean, that's how you would solve for tension, chapter 5 style. My advice would be to solve for tension, chapter 4 style. I think it's easier. I think it's easier to do it the old way. You know, free body diagram, sum the forces, and then find tension from there. So anyway, any questions on part A? The idea is the work net equals 0, so the work done by tension has to equal the work done by friction. Okay, part B. Now this is easier. How much work is done by the rope? How much work is done by tension? So now that we know that the tension is 79.4 newtons, so this is easy now. So part B, finding the work done by tension, what are we going to do? Cosine 20t, right? Take the x component of tension and then multiply by the displacement. So the work done by tension is going to be cosine 20 times 79.4 newtons times the displacement, which is 20 meters. And this gives us work of tension equal to 1,492 joules. Okay? And then part C, what is the mechanical energy lost due to friction? Look at energy lost due to friction is the same as the work done by friction. Because what's the unit for energy? They're asking for the energy lost due to friction. Energy lost due to friction. What's the unit for energy? Joules. What's the unit for work? Joules. Look, we can figure this out very, very quickly. What is the net work? The net work is equal to what? So this object is moving at constant speed. So what does that tell us about the total work done? Up here. Look at work net equals change of kinetic. If the object moves at a constant speed, what's the change of kinetic? 0. So what's the net work? 0. So the net work is going to be work of tension minus the work of friction. But what is the net work for this problem? 0. So that means that the work done by the tension is equal to the work done by the friction. We already know the work done by the tension. It's 1,492. Right? In other words, the work friction is canceling the work done by the tension. And that's why the box moves at constant speed. Now look, could you have solved for that another way? Could you have done part C a different way? Yeah, it's much more time consuming. What you could have done for part C, I'll just show you real quick. Another solution. What you could have done for part C to find the work done by friction, because that's the energy, you could go friction times displacement and then calculate what friction is. You know, what's the equation for friction? Right here. Friction is mu times normal force. Plug that in. And guess what you're going to get if you do that? You're going to get 1,492. If you solve for what the frictional force is and multiply by the displacement, You'll get the same thing. Yeah. Oh, it would. Yeah, it would be negative. Yep. Like right here, I had it negative. Right there. Negative just means opposite motion. Yep. Negative, it's opposite motion.